Hello, calculus. Here's this little video that I told you we would be doing. It's just the tail end of the limits at infinity. So we talked about what happens when we have asymptotes. And now we're going to look at some graphs that are kind of special. We don't really talk about these in pre-calculus, but there is a way to find the limit of these guys, even if you don't have a calculator. And so that's what we're going to talk about here. So what's special about this kind of graph that we didn't have before? And hopefully you're saying, well, before we only had one asymptote, Ms. Harris, this looks nasty. It's got two asymptotes. Let's try that. So there are two different horizontal asymptotes. And if you notice on the graph, one side approaches one, the other side approaches the other. So this one's going to this one. This one's approaching the other from underneath. Is that always going to be the case where if we go to the negative side, it's approaching the negative one, or the lower one and the right side to the upper one? I don't think so. Not 100% sure, but I don't think so. We are going to use some calculus though to find these things without a graph. But if we look at this graph in front of us, get this right. As x approaches negative infinity, where's this graph going to? -2. And as x approaches positive infinity, where is this graph going to? That other asymptote up there, which is at 2. And so we're going to talk about how we can find this using that same kind of algebraic analysis that we did, where we divide by the leading or the biggest term in our denominator. So looking at this example down here, which is this guy, we want to do just like we did before. We're going to take each term in there and divide it by the highest degree in our denominator. So normally, if there wasn't a square root, we'd say this is 2x over x squared minus 2 over x squared. But we don't have that under there. We've got the square root of x squared. So this is going to take a little bit more thinking on our half. Remember, the square root of x squared is just positive n minus x. But if you think about the square root, as we go off to infinity, this guy is just equal to x if x is positive. So when x is greater than 0, which is the case when we're going off to positive infinity, x is greater than 0, so we have just x. So then this guy here, which is the square root of x squared, that's just going to be x if we're going off in the positive direction. So each of these guys are only going to be divided by this x, not by the square root of x squared. And then on the bottom, I've got the square root of x squared over x squared. Nothing changes down here, plus 1 over x squared. All right, and then we do the same thing that we did before. These guys would cancel out, so this is really the limit. As x approaches positive infinity of 2 minus 2 over x. On the bottom, I got the square root of 1 plus 1 over x squared. And now as x blows up and gets really, really big, what happens to those fractions where x is in the denominator? They get really small. So this is 2 minus 2 over infinity, which goes to 0. All of the square root of 1 plus 1 over infinity squared. So 2 minus 0 over the square root of 1 plus 0. That's 2 over 1, which is 2, which is what we said up here. Whoop, sorry. Which is what we said right here. When it goes to positive infinity, we're going to positive infinity, or positive 2. Well, then how do we find it if it's going to negative infinity? Well, remember, if x is less than 0, so if x is negative, then the square root of x squared is going to be negative x. So when we're looking as our x's go to be negative all the way out to negative infinity, instead of plugging in a positive x, we're going to plug in a negative. So this would be the limit as x goes to negative infinity of 2x over, well, the square root of x squared we said is negative x, minus 2 over negative x, all over the square root of x squared over x squared. This doesn't change. Why does this not change? Because it's still inside that square root sign, right? All right, and so this would be the limit as x approaches negative infinity. My x would cancel out, and I've got negative 2. And this would be plus 2 over x. As the minus becomes positive. On the bottom, I've got the square root of 1 plus 1 over x squared. And And now as this guy goes to infinity, it's going to be minus 2 plus this guy's going to go to 0 over the square root of 1 plus 0, and that guy's going to go to negative 2. And that's what we saw in our graph. So we could find this one by looking at the graph of it, but we can also find it algebraically using that same algebraic analysis with limits and infinity like we did before. So if we go down to our notes, we got 2 more examples here, and then we're going to work through 2 examples tomorrow. Plus we'll go over our quizzes and any questions you have off of the review sheet. All right, so if we're going to negative infinity here again, this will be the limit as x approaches negative infinity of 3x. Square root of x squared, when we're going on the negative side, is going to be negative x minus 2 over negative x, 2x squared divided by x squared plus 1 over x squared. As this guy goes to negative infinity, the x's would cancel here, and I just have negative 3. This guy would go to positive 2 over negative infinity, which is going to go to 0. On the bottom, I've got the square root of 2, because the x's cancel. And then 1 over x squared is going to go to, whoops, not 1 over 0, Miss Harris. It's going to go to 0. So this guy's going to go to the negative 3 over the square root 2. So if I asked you what is true about that guy, you could say, since the limit as x goes to negative infinity of 3x minus 2 over the square root of 2x squared plus 1 is equal to negative 3 over the square root of 2, what we know about this guy is that there's a horizontal asymptote at y equals negative 3 over the square root of 2, and that the end behavior goes to that asymptote on the left-hand side. All right, same thing up here for this guy. Again, we're looking at the more interesting case when x goes to negative infinity. As x goes to negative infinity, this guy is going to be x squared over negative x plus 2x over negative x, all over the square root of 3x squared over x squared plus 2 over x squared. Now this time only one of these x's cancels out here, so I still have a negative x here. So negative, let me do it this way. The limit as x goes to negative infinity, I still have a negative x, and then minus 2 all over the square root of 3 plus 2 over x squared. And now as we go to negative infinity, I'm going to plug in that negative infinity for x, because this guy doesn't go to 0, right? So negative infinity minus 2 square root of 3 plus, this guy will go to 0 because it's in a fraction. And so what's a minus infinity? It'll be positive infinity. The minus 2 is negligible. On the bottom, we're dividing this guy by the square root of 3. Again, that's negligible. So this limit of this guy here would be to positive infinity. So what does it mean if it's going to positive infinity? Remember, if your end behavior goes to positive or negative infinity, it means you don't have a horizontal asymptote. And we can graph that in a calculator to verify it. All right, that is it for today. We'll talk about the 2 examples that were in our classwork from the other day. We'll do those tomorrow in class. Come prepared to ask any questions you have about the review sheet, and I'll be handing back the quizzes, and we'll talk about that as well. You guys have a great night.